Okay, let's move to the next question. So before I explain that one, let me draw the graph. Okay, so on the meantime, you have to read that question, try to understand what are the given things and what do you want to find. Okay, so let me draw that graph. Okay, so I tried to draw a rough graph here. So here you can see that this one PBT, that one is a tangent, and there is a angle O1 at the center. That angle is, it is given as 310 degrees. So of course now you have an idea how can you find O2, 360 minus 310, 50 degrees. Okay, anyway, now that's all given. So O1 is given as 310 and this one is a tangent and the remaining lines are given. Okay, so what is the first question? Calculate giving reasons the size of first one D1. So first question is 8.1. You have to find D1. Where is D1? This angle. So how can you find a D1? How can you find D1, guys? D1. D1 means which angle is D1? This angle. Okay, so you have to find that angle. Okay, so now look at let me quickly explain that one. So here this angle is O1 is 310. Angle O1 is 310. It is given. So what about this angle? The remaining angle 360, total angle around a point is 360. So that 360 minus that 310. Okay, so O1, I mean O2, first of all let me try to find O2. Angle O2 is equal to 360 minus 310. So what is the reason? Angle arrow or angles around a point. So angles around a point is 360. Okay, so O2 is equal to, therefore O2 is equal to 360 minus 310 is 50 degrees. Okay, so O2 is equal to 50 degrees. So what is this angle? 50 degrees. Okay, now what is our question? Our question is to find angle D1. Don't forget that. Okay, now actually what is this O2? O2 is coming from which chord? B and C. Am I right? O2 is coming from the points B and C. Okay, so from that point B and C, can you see this O2 is, what is that one? 50 degree, and that is the angle at the center. Am I right? From this point B and C, this angle formed at the center, that is angle at the center, it is 50 degree. Okay, so from the same point B and C, that is very important, it must be from the same point. Okay, from the same point B and C, can you see this angle is formed? Which angle is that? D1, angle at the circumference. Okay, so what is the theorem we studied? Angle at the center is 2 times angle at the circumference. Am I right? That is the theorem you studied. Angle at the center is 2 times angle at the circumference. So what about the next step? What is D1? Therefore angle D1 is equal to 50 divided by 2, that is 25 degrees. What is the reason? The reason you have to write, you must have to write, otherwise you will lose 1 mark. Okay, what is the reason? Angle at the center is equal to 2 times angle at the circumference. Okay, so this angle is 50 degree, so the angle at the circumference is 25 degrees. Okay, so what is a D1? 25 degrees. So it's better to write that the angles that we got there on the diagram. Okay, so D1 is 25 degrees. So angle at the center is 50 degree, so angle at the circumference is 25 degrees, half of this one. Okay, or double of this one is 50. Okay, so that is question number 8.1. Now let's move to 8.2. What is question number 8.2? Angle B3. Where is angle B3? Okay, you have to find angle B3. Which one is angle B3? This angle. So how can you find that angle, guys? How can you find that angle B3? Actually, what is that angle B3? First of all, you have to think about that. What is this angle B3? That is an angle between this tangent PBT angle between the tangent and this chord. Which chord is that? BC. Is it not so? Okay, this angle B3 is an angle between this tangent and this chord BC. Okay, so you studied the tan chord theorem. What is that tan chord theorem? Tan chord theorem. What is that theorem? The angle between the tangent and the chord is equal to the opposite angle. So what you have to do? You have to check the chord. Which one is the chord here? BC is the chord. And where the angle makes on the circumference, this BC is going here up to D1, and we already got D1 as 25. Am I right? Okay, so what is this B3? B3 is also 25. So B3 is also 25 degrees. What is the reason? Tan chord theorem. You must have to know tan chord theorem. So here before I write the answer, look at once more. Let me draw that one here. This is a, assume that this is a tangent, okay, and this one is a chord. So this is our B3. Okay, this is our point B and C, and this tan chord theorem saying the angle between the tangent, this is the tangent, okay, and this is the chord. That angle between the tangent and the chord is equal to, from these points B and C, we have to draw on the circumference. Okay, and it is already, we already got, this is D1. We already got this angle as 25 degree. So that 25 is equal to this 25. You understand? So these two angles are equal. That is tan chord theorem saying. Okay, so now let's come back to this one. So how can you write the answer? Angle B3, we can directly write angle B3 is equal to 25 degrees. But you must have to write the reason. What is the reason? Tan chord theorem. Because of tan chord theorem, this B3 is also 25 degrees. You understand? Okay, so that is question number 8.2. Okay, now let's move to the next question, 8.3. Okay, let's move to the next question, question number 8.3. Question number 8.3. What is that question? Angle B1. You have to find angle B1 if it is given that angle A is equal to 60 degree. So it is given in the question that angle A is 60 degrees. If it is given that angle A is 60 degree, what do you want to find? Which angle you want to find? Angle B1. You have to find this angle, angle B1. Okay, that is a question. Now listen here, listen very carefully. Here, look at these points B, C, D, A. What is that one? B, C, D, A. That is a cyclic quadrilateral. Am I right? B, C, D, A. That one is a cyclic quadrilateral because all those four points are on the circumference of the circle. And you studied that opposite angles of a cyclic quadrilateral are equal. So here, look at this one. This angle is given as 60 degree. So can you say what is this angle? 180 minus 60. You know, in a cyclic quadrilateral, let's say this is a cyclic quadrilateral. Okay, A, B, C, D. I'm just giving another example. Okay, so if this one is 70 degrees, okay, there it is 60 degree, then here it is 110 degree. Why? When you add these two angles, you are supposed to get opposite angles. Okay, when you add this one, you are supposed to get 180 supplementary. So 70 plus 110 is 180. So similarly here, this angle A and angle C are supplementary angle because opposite angles of a cyclic quadrilateral. So if this one is 60, what is this one? 180 minus 60. What is 180 minus 60? 120 degrees. So now look at this one. 120 plus 60 is 180. Okay. So first of all, we can write that one. What is that angle? Angle BCD. So first we can write angle BCD is equal to 180 minus 60. So angle BCD is equal to 180 minus 60 is 120 degrees. Okay, and what is the reason here? You must have to write the reason. Opposite angles of a cyclic chord. Opposite angles of a cyclic quadrilateral. So since this one is 60, the opposite angle is 120 degrees. Now look at this one. Here this angle is look at this triangle BCD. I'm talking about the triangle BCD. Which triangle I'm talking? Triangle BCD. Look at that triangle. Identify that triangle there. Angle BCD. Angle BC. Triangle BCD. This angle. Okay. So in that triangle BCD, we know that this angle is 25, and now we know that this angle is 120. So what about the remaining this angle? What about that remaining angle B2? This is angle B2. Okay, so how can you find that one? In a triangle, what is the sum of the angles? Sum of the angles in a triangle is 180. So this is 120, this is 25. So what is remaining here on this angle? 180 minus 120 plus 125. Okay, so let's find that one. Also B2 is equal to angle B2 is equal to 180 minus 120 plus 25. So check in your calculator. What is the reason for that? Sum of the angles in a triangle. So reason is sum of the angles in a triangle. Okay. So check in your calculator. What is B2 now? 180 minus 160, 60 minus 25, so 40, 35. So angle B2 is equal to 35 degrees. So it means that this angle is 35 degrees, angle B2. But still we are not there. What is our question? We have to find this angle B1, not B2. But we got B2 as 35, and what is B3? B3 is 25. Okay, now listen here. When I explained that theorem, I told you, if this one is a circle, this is the center of the circle, and this one is, what is the name of this line from the center? That is a radius. Am I right? Okay, and assume that this is a tangent passing through this point. Okay, and what is this angle? What is this angle? 90 degree. What is the reason? Radius is perpendicular to tangent. Always radius is perpendicular to tangent. Okay, so now look at this diagram. From this point O, can you see this line? What is the name of that line? That is a radius, isn't it so? That OB is the radius. And what is this line? That is a tangent. This one is a tangent. So what is this angle now? We know that radius is perpendicular to tangent. That means when you add B1, B2 and B3, you are supposed to get 90 degrees. Am I right? B1 plus B2 plus B3 is 90 degrees. Okay. So here, next step, you have to write, but B1 plus B2 plus B3 is equal to 90 degrees. What is the reason for that? Radius is perpendicular to tangent. Am I right? This B1, this is B1, this is B2, and this one is B3. When you add that one, all that angle, that is 90 degrees. Okay, so B1 plus B2 plus B3 is 90 degrees. B1 we have to find. Am I right? We know what is B2 and B3. B2 is 35 and B3 is 25. So substitute there. B1, angle B1 plus B2 is 35. 35 plus B3 is 25. And the answer is 90 degrees. So from here, what is B1, angle B1? You have to take this one to the other side. So 90 minus 35 plus 25. So check in your calculator, what is the answer for that one, angle B1? 90 minus 35 minus 25. So check in your calculator. So you will get 30 degrees. So what is angle B1? B1 is equal to 30 degrees. So now this angle, that is a question. We have to find angle B1. So what is angle B1? B1 is 30 degrees. So if you add this one, 25 plus 35 plus 30, you will get 90 degrees. That means radius is perpendicular to tangent. You understand? Okay. So that is this second question, question number 2. So I hope you understand. Now let's move to the next question. Okay. Okay, let's go to the next question. Question number 3. Here, first let me draw the diagram. Then after that, based on that one, I will explain. Okay. So there is a circle like this. Okay, I try to draw a rough sketch here. Now, based on this one, here ED, this one is a tangent. Am I right? This line ED is a tangent, and it is given that this angle is 40 degrees. Okay, that angle is 40 degrees, and also it is given that this angle is 65 degrees. Okay, now based on this graph, you have to draw, we have to find the that two questions. Okay, what is the first question? 8.1.1. What is that question? Calculate, determine giving reasons the size of each of the following angles. So D2, first question, you have to find this angle D2. So how can you find that angle D2? So first, before you watch this video, you have to pause the video and try to find yourself. Okay, then after that watch this video. Okay, so here what is the question? You have to find the angle D2. This is the angle D2. Am I right? This angle is D2. Okay, so here what you have to do is look at this line OD. Look at the line OD. Can you see the line OD? And what is that line OD? O is the center and D is on the circumference. That means this OD is a radius. Am I right? Okay. Now, what about this line ED? This line ED is the tangent. Am I right? So, you studied a theorem like this. Radius is perpendicular, not this one, not a chord, sorry. You studied a theorem, radius is perpendicular to tangent. Am I right? Okay, if this one is a radius and this is the tangent, then this angle is 90 degrees. So here you can see that this is the radius and this one is a tangent. So what is this angle? This angle is supposed to be 90 degrees, that D2 plus D3. Okay, so this angle is 90 degree because radius is perpendicular to tangent. Am I right? Okay, so here first of all we can write D2 plus D3 or ODE. Is it not that one? ODE. Okay, so D2 plus D3, that one is equal to 90 degrees. What is the reason? Radius is perpendicular to tangent. D2 plus D3 is 90 degrees because radius is perpendicular to tangent. Now don't forget what is our question. We have to find this angle D2. Okay, so here what is D3? D3 is given as 40 degrees. Am I right? So D3 is 40 degrees. So it means D2, therefore D2, sorry, D2, angle D2 plus D3, it is given as 40 degrees. So D2 plus 40 degrees is equal to 90 degrees. So from here what is D2? Angle D2 is equal to 90 minus 40. So what is that one? D2 is equal to 50 degrees. So it means that this angle D2 is 50 degrees. Okay, so listen once more. What is the question? You have to find D2, angle D2, this angle. Okay, so how can you find that one? We know that this OD and this tangent are perpendicular. Radius is perpendicular to tangent. That is a theorem. Radius is perpendicular to the tangent. This angle is 90 degree. Okay, so it means here this angle D2 plus D3 is 90 degrees. Okay, so this one is D3 is 40 degree, it is given. So what is the balance? 90 minus 40, that is 50 degrees. Okay, so that is question number 1, 8.1.1. Now let's move to 8.1.2. okay. Okay, now let's move to the next question, 8.1.2. 8.1.2. What is that question? Angle FBC. Look at that question. You have to find angle FBC. Which one is FBC? FBC. That means you have to find this angle. That is the question. Okay, angle FBC. What is angle FBC? That is a question. Okay, so how can you find that one? So here, look at this one. This is how I am thinking. Look at this point, B C A D or B C D A. This one is a cyclic quadrilateral. Am I right? B C A D or B C D A is a cyclic quadrilateral. In that cyclic quadrilateral, this angle that we want to find, that is an exterior angle. Is it not so? In this cyclic quadrilateral, this angle is an exterior angle. What is the theorem we studied? Exterior angle is equal to opposite interior angle. That means this one. Okay, so here this is the exterior angle and this angle is equal to opposite interior. That means this D1 plus this angle, D1 plus D2. Okay, so if we can find what is D1 plus D2, then we can say that that one is the same as this exterior angle. You understand? Okay, so we have to find this one, and what is the theorem? Exterior angle is equal to opposite interior angle. That means this is the interior angle and the opposite is this D1 plus D2, not D3. D3 is not included there. Okay, so D3 is not included because we are considering this cyclic quadrilateral DABC like this. Okay, so D3 is not there. So we just want to consider this angle. What is this angle? D1 plus D2. Okay, so D2 we already know that it is 50 degrees. So if we know this D1, then we can find what is D1 plus D2. Okay, so how can you find D1? Look at this line OC and OD. These two lines are equal. Can you say why? Because that's the radius of the same circle. Okay, so this OC is equal to OD. So let me write that one first. OC is equal to OD. What is the reason? Radius of the circle. Okay, so if these two lines are equal, then the opposite angles are also equal. In an isosceles triangle, if these two sides are equal, then the opposite angles are also equal. So in this triangle, this is an isosceles triangle. These two sides are equal means the opposite angles are also equal. So here what is opposite angle? Here what is angle? 65. So what is this one? This one is also going to be 65. Opposite angles are equal. Okay, since these two sides are equal, then the opposite angles are also equal. So now we know that it implies that angle D1 is also 65 degrees. What is the reason? Opposite angles of equal sides. Opposite angles of equal sides. So now we know what is D1 65 and what is D2 50. So what is D1 plus D2? Therefore angle D1 plus angle D2, that is 50 plus 65. 50 plus 65 is what? 115. D1 plus D2 is 115 degrees. Okay, now is it not that one is the same as, do you remember I told you exterior angle is equal to opposite interior angle. So what is this one total? 115 degrees. So is it not that the same as this one? So next step we can write, it implies that angle FBC is equal to 115 degrees. Okay, and what is the reason you have to write? You have to write the reason as exterior angle of a cyclic quadrilateral. Exterior angle of a cyclic quadrilateral. Exterior angle of a cyclic quadrilateral. So this is an exterior angle. So this angle is equal to opposite interior. That means this D1 plus D2. So now we know that D1 plus D2 is 50 plus 65, that is 115. So it means that FBC, the angle FBC is also 115. What is the reason? Exterior angle of a cyclic quadrilateral. So that is that question. Now let's move to the next one. Okay. Okay, let's move to the next question. So like always, let me draw that diagram first, then after that, based on that one, I will explain. Okay, so there is a circle given like this. Okay, I tried to draw a rough sketch there. Okay, so what are the given things here? So this is the center of the circle, and here you can see that this is from the center to the chord, and this angle is 90 degree. So it's already from this picture itself we can understand that this RT and TM are equal in length. Do you remember that theorem? Line from the center to the perpendicular line, perpendicular, this is center O, perpendicular line from the center bisect the chord. So here this line is from the center and this is perpendicular, so it means that this RT and TM are equal in length. Okay, anyway, let's leave that one. It is given that 15 degrees and this angle is 32 degrees. Okay, now based on this given informations, we have to answer the remaining questions. Okay, so what is the first question? Calculate with reason the size of angles. First one, S, angle S. What is angle S? This angle. How can you find that angle? So here that angle, when you have a question like this, that angle is formed from which two points? That is what you actually, we are saying which segment. Okay, so you just try to understand like this. Okay, from which two points that angle is coming? This angle is coming from which two points? From P and M. Am I right? From these 2 points P and M, that angle is coming. Okay, so you have to check that from the same point P and M, where else it is going? It is going to the center, and also it is going to where? To this R. Okay, and it is given that R is, what is R? 32 degrees. So look at that one. From the point P and M, it is going to the circumference and R, that is angle R, and that is 32 degrees. So from the same point it is going to S, and we have to find this S. So what is that S? Angle S is what? Directly we can write, you studied a theorem like this. Angle in the same segment from this point, let's say this is AB. Okay, this is this angle, and from the same point A and B, if you get another angle in the circumference, then these two angles are equal. Am I right? Okay, so what is the theorem? That one, angle in the same segment are equal. So look at this one, from the same segment, so these two angles are equal. So what is angle S? Angle S is also 32 degrees. What is the reason? Angles in the same segment. Angles in the same segment. That's enough. Angles in the same segment are equal, or you can write equal. Okay. So that is question number 1. Now let's move to the next one. Question number 2. What is that question? Angle O2. Look at that question. You have to find O2. Okay, so once if you get an answer here, it's better to write that answer here, 32 degrees. Okay, now what is the next question? Angle O2. What is angle O2? Which one is angle O2? This angle. Am I right? So that angle is coming, like what I said on the previous question. You have to check that angle is coming from which two points. Okay, or the segment. Okay, so this angle, this is the angle at the center. Am I right? Okay, so this angle is coming from which two points? From P and M. Am I right? From P and M. So from the same point P and M, this is the angle at the circumference, or this is the angle at the circumference, any one you can take. Okay, from the same point P and M, this is the angle at the circumference, and this O2 is angle at the center. Angle at the circumference, angle at the center. What is the connection between that? Yeah, you studied a theorem. Angle at the center is 2 times angle at the circumference. So this one is 2 times this one. Okay, so here angle at the circumference is 32. So what is angle at the center? Is a double of that one. So 32 double is 64. So here what we can write, angle O2. Angle O2 is equal to 64 degrees. What is the reason? Angle at the center is equal to 2 times angle at the circumference. Angle at the center is 2 times angle at the circumference. So now we know that angle O2 is 64 degrees. You understand? Okay. So that is question number 2. Now let's move to the next question. Question number 3. What is question number 3? Question number 3, angle O1. Okay. You have to find O1. How can you find O1? That's a simple question, is it not so? Look at this one. This is angle O1. You have to find this angle. So what is this angle? It is given that 90 degrees. What is this one? 15 degrees. So what is O1? Yeah, in a triangle, in a right angle triangle. This is a right angle triangle. Am I right? Okay. Yeah, anyway, right angle triangle or any triangle. Okay. This angle is 90 degrees. This is 15 degrees. So how can you find sum of the angles in a triangle? Okay, so angle O1 is equal to 180 minus, what is the sum of the angle? Sum of the angles in a triangle, 180. So 180 minus 90 plus 15. Check in your calculator, what is angle O1? 180 minus 90, 90 minus 15 is 75. So angle O1 is equal to 75. Here you have to write, what is the reason? Sum of the angles in a triangle. Sum of the angles in a triangle. So angle O1 is equal to 75 degrees. You understand? Okay. So that is that question. Now let's move to the next question. Okay. Okay, first let me draw that diagram, then based on that one we can answer the remaining question. Okay, so there is a diagram, there is a circle given like this. Okay, I try to draw a rough graph here. So based on this graph we have to answer the remaining questions. Okay, so here what are the given ones? This angle is 30 degrees and this is center O, and this angle is given as 90 degrees. Yeah, then the remaining points are given. Okay, now what is the first question? 8.1.1, determine stating reason the size of angle S. So first question, 8.1.1, you have to find angle S. Where is this angle S? Angle S, this angle. Am I right? Okay, so you have to find what is that angle S, this angle. That is the first question. Okay, so now look at this one. This S line SR, is it not a diameter, that one? SOR, O is the center, so SR is the diameter. Okay, so from that diameter, can you see from this point SR, diameter points S and R, look at this angle is coming. So can you say what is this angle? Yeah, angle in a semicircle. You studied a theorem like that. This one is 90, this is the diameter. Then what is this angle? This angle is 90 degrees. So it means that this P1 plus P2, that angle is going to be 90 degrees. What is the reason? Angle in a semicircle. Okay, so first we can write that one. Angle P or P1 plus P2, both are the same thing. Okay, angle P is equal to 90 degrees. What is the reason? Angle in a semicircle. Angle in a semicircle. Angle P is equal to 90 degree. Okay, now look at this triangle PSR. What is our question? We have to find angle S. Am I right? Okay. So look at the triangle PSR. In this triangle PSR, locate that triangle PSR. In this triangle, this angle is 90 degrees and this angle is 30 degrees. It is given that this angle is 30 degrees. So how can you find this angle? Yeah, sum of the angles in a triangle is always 180 degrees. So this is 90, this is 30. So the remaining angle is 180 minus 90 plus 30. Okay. So therefore angle S is equal to 180 minus the remaining angle 90 plus 30. 90 plus 30 is 120. So angle S is equal to 180 minus 120, that is 60 degree. What is the reason here? Sum of the angles in a triangle. You have to write that reason. Sum of the angles in a triangle. So what is answer? Angle S is equal to 60 degree. So once if you get the answer, it's better to write with a pencil or in that question paper. Okay. So that will make your work easy to get the next question. Okay. Okay, so that is angle S. Angle S is equal to 60 degrees. Now let's move to the next question. Question by 8.1.2. 8.1.2. What is that question? Angle R1. You have to find angle R1. Which one is R1? Okay, this angle is R1 and you have to find that angle. How can you find that angle, guys? Look at these 2 points, point P and point R. Okay, now listen very carefully. Look at the point P and R. Look at the chord PR. Okay, so from that chord PR, can you see this angle is coming? Look at the point P and R, then this angle is coming, that is 60 degrees. Do you understand? Okay, from the point P and R, this angle is formed, that is 60 degree. And from the same point P and R, look at this one, where it is going, N1 and N2. This N1 and N2 from the same point P and R. Can you see that? Okay, so from the same point P and R, this angle is 60 degree. So from this P and R, so what about this angle? That N1 and N2 is also 60 degree. What is the reason? Angle in the same segment. Okay, so next first we can write angle N1 plus angle N2. N1 plus N2 is also 60 degree. What is the reason? Angles in the same segment. Angles in the same segment. Do you understand? From the same P and R, this is 60 degree and this one is also going to be 60 degrees. Do you understand? Okay. So now look at this triangle TRN. What do you want to find? What is the question? You have to find the angle R1. Okay. So look at this triangle TRN. This triangle. What is this angle T1? 90 degrees. What is this angle R1? We don't know. That is what you have to find. Okay. What is this angle N1 plus N2? 60 degree. I am talking about which angle? TRN. This is T, this is R, and this one is N. N1 and N2 here. Okay. So this total angle is 60 degrees. And we know that this angle is 90 degrees. So what is the remaining angle, this R1? How can you find R1? Therefore R1 is equal to 180 minus then 90. So maybe if you want to write, if you want to understand clearly, you can write here in triangle TNR. So it will be more clear. Okay, in triangle TNR, which triangle we are considering? TNR. Okay, R1 is equal to 180 minus 90 plus 60. So 180 minus 90 plus 60, that is angle R1. 90 plus 60 is 150. So remaining is 30 degrees. So it means that this angle R1 is 30 degrees. You understand? Okay. So listen once more. From the chord PR, or from the points P and R, this angle we all know that 60 degrees. So from the same point P and R, this angle is also formed N1 plus N2, that is also 60 degree. If this one is 60, this is also 60. What is the reason? Angles in the same segment. Okay, so now after that, when you consider this triangle, this is 90 degrees, this is 60 degrees, so the remaining is 30 degrees, sum of the angles in a triangle. Okay, so that is question number 8.1.2. now let's move to the next question. Okay, now let's move to the next question, 8.1.3. question number 8.1.3. what is that question? Angle N1, you have to find angle N1. Which one is angle N1? This angle. We know that the N1 plus N2 is 60 degree, but here the question is to find N1, only N1, that angle, that small angle. Okay, so how can you find that one, guys? Now look at these two lines ON and OR. What is that two lines? ON and OR. Is not these two lines equal? It's the radius of the same circle. Am I right? Okay. So ON is equal to OR. Here ON is equal to OR. What is the reason? It's a radius. Am I right? So if ON and OR are equal, then the opposite angles are also equal. So what is the opposite angle of this side? ON, 30 degrees. So what is the opposite angle of this side? OR, that is this N2. So N2 is also going to be 30 degrees. What is the reason? Opposite angles of equal sides. So it implies that R1 is equal to N2, okay, is equal to 30 degrees. What is the reason? Opposite angles of equal sides. Opposite angles of equal sides. So now we know that N2 is also, it implies that N2, angle N2 is also 30 degree. So here what is our question? We have to find angle N1. So what is N1 plus N2? It is 60 degrees. N1 plus N2 is 60 degree. And now we know that this N2 is 30 degree. So what is this N1? 60 minus 30. Am I right? Total angle is 60. This total angle is 60. And this small angle is, this N2 is 30 degree. So what is N1? N1 is also 30. Then only 30 plus 30 you will get 60 degree. Okay. So it implies that angle N1 is equal to 60 minus 30 degrees. So angle N1 is equal to 30 degrees. So now we know this one is also 30 degrees. Do you understand? Okay. So that is question number 8.1.3. Now let's move to next question, 8.2. Let's move to the next question, 8.2. What is that question? If it is further given that NW is equal to WR, prove that TNWO is a cyclic quadrilateral. Wow. What is that question? It is further given that NW is equal to WR. So now they are given that these two sides are equal. This is NW, this one is NW, and this one is WR. So it is given that these two sides are equal length. So if these two sides are equal length, look at this one. This is coming from the center. It is coming from the center and it is given that these two sides are equal length. So what is the meaning of that? This angle is going to be 90 degrees. Do you remember that theorem? Okay. It is coming from the center and bisecting. Then it is coming from the center and this one chord bisects. So what is the meaning of that? That angle is 90 degrees. You remember that one? Okay. So here it is given NW and WR are equal. So it means that we know that W2 is 90 degree. So first of all we can write that one. Okay. Then we can think about what we want to prove. Okay. So W2, straightforward we can write W2 is equal to 90 degrees. What is the reason? Line from the center, these two are equal means this is the midpoint. Okay. So line from the center to the midpoint of a chord is perpendicular. Okay, so it's enough to write like this: line from the center to the midpoint of a chord. So it is of course that it is 90 degrees. It is 90 degree. So what is the reason to say this angle is 90 degree? W2 is 90 degree. Line from the center to the midpoint of the chord. So that angle is 90 degrees. Okay. Now look at the question once more. What is the question? What do you want to prove? Prove that TNWO is a cyclic quadrilateral. You remember what is the meaning of cyclic quadrilateral? All the points are on the circumference of the circle. Then this one is known as a cyclic quadrilateral. Okay. Now here in this question we have to prove that TNWO. Which one is that point? Which one are those points? T. This is one point. N. W. O. These 4 points are cyclic quadrilateral. You have to prove that that one is a cyclic quadrilateral. So look at this one here. Assume that there is a circle something like this, a new circle connecting T, N, W, O. You want to prove that all these 4 points are on the circumference of that circle, new circle. You understand? That is what you want to prove. Prove that these points T, N, W, O are on the circumference of the new circle. Okay. So how can you prove that that one is a cyclic quadrilateral? That is what we want to think. Okay. So now look at this one. That TNWO, let me draw that line here, thick line. Okay. TN. Can you see that this one? Okay, and here what is this angle T1? T1 is 90 degree. It is given that T1 is 90 degree. Now let me extend this one to this side. This is, can you see that this one is also 90 degree? We proved that one, W2 is 90 degree. Okay, so now look at how I am going to write. T1 is equal to T1, angle T1 is equal to 90 degree. That is given in the question. Angle, this angle is 90 degree. It is given. Okay, given. So what is the meaning of that one? It implies that angle W2 is equal to angle T1 is equal to 90 degree. So it means that this angle W2 and this angle T1 are equal, 90. Okay, so actually what is that two angles? This is an exterior angle and this is the opposite angle, and this is the interior. W1 is the interior and opposite. That means exterior angle and the opposite interior angle are equal. If exterior angle is equal to opposite interior angle, then we can say that this one is a cyclic quadrilateral. Okay, so next step, directly we can write, therefore T N W O is a cyclic quadrilateral. Now there is no mark for this sentence, okay, but the final mark is for the reason. What you are going to, why you are saying that this, you said that W2 and T1 are equal, okay, then you are saying that this one is a cyclic. What is the reason for that? The last mark is for this reason. What you are going to write the reason? Exterior angle is equal to opposite interior angle, am I right? Okay, but here try to understand, keep that like that in your mind. If the question in your question paper, if the question is to prove that T and W is a cyclic quadrilateral, then you have to write converse of. Okay, so let me write here like this, then after that I will explain. Converse of exterior angle is equal to opposite interior angle. Okay, why we wrote this converse? Why we wrote this one? It is must that you have to write it like this, and I told you when you want to write. If the question is to prove that this one is a cyclic quadrilateral, then you have to write converse of angle in the same segment. Converse of exterior angle is equal to opposite interior angle. Converse of opposite angles are supplementary. Okay, so if you want to prove that this one is a cyclic quadrilateral, when you write the reason, you have to write converse of. Okay. Now, what is the reason why we are writing converse? Listen here. What you studied the theorem? You studied the theorem like this. If this one is a cyclic quadrilateral, then exterior angle is equal to opposite interior angle. That is what you studied. Listen very carefully. Okay. What is the actual theorem? If this one is a cyclic quadrilateral, then exterior angle is equal to opposite interior angle. Am I right? But here what we are saying? Here we are saying that exterior angle is equal to opposite interior angle. Therefore, this one is a cyclic quadrilateral. That is why we are writing converse of. Listen once more. Erase that one. Listen once more. Okay. What is the actual theorem? Actual theorem saying if this one is a cyclic quadrilateral, then exterior angle is equal to opposite interior angle. Do you agree that one? That is the actual theorem. If this one is a cyclic quadrilateral, then exterior angle is equal to opposite interior angle. Okay. But here what we are saying, because of this exterior angle is equal to opposite interior angle, this one is a cyclic quadrilateral. That is why here we are writing converse of. You understand? Okay. So that is the theorem. That is what we want to prove. That one is a cyclic quadrilateral. I hope you understand. Okay. So let's go to the next question.